Hi. In the last session, we talked about the std underscore logic underscore vector data type, and we talked about the array attributes. We also discussed how you can use those array attributes to code your VSDL designs more effectively. Now, in this session, we will be talking about another most important data type, which is integer. And I will tell you about the best practices of using integers in your VSDL designs. So, integer data type is designed to represent the whole numbers. However, VSDL does not specify the width or size of bits for the integer values, but most VSDL implementations provide at least 32 bits of data to store these integer values. This ensures a broad range for your numerical calculations within the FPGA circuits. VSDL offers the integer data type as a fundamental building blocks for representing the whole numbers in your FPGA designs. Unlike some other data types which require some specific packages to include in your VSDL code, integers are by default available within the VSDL programming itself. So you can use them straight in your VSDL codes without worrying about any package declaration. Integers are quite useful in applications such like counters and array indexing, etc. And they make integers a popular choice for various VSDL designs. Okay, now let's see how to define integers in VSDL. The first example is the basic way to declare an integer signal in the VSDL, which is signal sig a colon integer semicolon. This signal a can have any value between minus 2 to the power 31 to the plus 2 to the power 31. The second example declares an integer called signal b, and this have the same range like signal a, but it is just initialized to the some starting values like we discussed about the initial assignments earlier. However, these two examples like declaring signal A and declaring signal B are valid ways to create the integer signals, but this approach is actually not recommended because the implementation may allocate 32-bit registers to implement these integers. This is fine if you actually need a 32-bit number for your data, but in most cases we do not need such a wide range. Hence, most of the hardware resources will be wasted if you practice this type of declaration in your VSDL designs. There are more resource efficient approaches which we should consider for our VSDL designs. So, to avoid such unnecessary resource uses, the best way is to limit the range of your integer. The next two examples demonstrate this efficient approach of declaring integer signals by specifying a range of allowed values. So here is the syntax: signal, signal name, colon, integer, range, minimum value to maximum value, semicolon. For example, signal 6c colon integer range 0 to 255 semicolon. In this case, the signal C can only hold the values from 0 to 255, and this will offer significant advantage to your VSDL designs. First is resource efficiency. Now the FPGA can implement signal C using a smaller register, potentially a 8-bit in this example, because it only needs 8 bits to store the values within this limited range. This translates to the more efficient hardware utilizations. Second is the code clarity. Specifying the range enhances the code readability because it clearly documents the valid values which signal C can take. This makes your designs easier to understand for you and others. You can also initialize your signal with some initial value, like the same way we did earlier. You can refer to the last example here. So signal, signal name, colon, integer, range, minimum value to the maximum value, colon equals to initial value, semicolon. For example, signal sig d colon integer range minus 128 to 127 colon equals to 35 semicolon. Here signal d has a range of minus 128 to the plus 127, and it will get the initial value of 35. By adopting this range constraints, you can create more efficient and readable VSDL codes while also optimizing the resource uses in your FPGA designs. Now let's quickly look at the integer signal assignments. VSDL allows the assignment between the integer signals as well, like we did for the std underscore logic signal types. So the syntax is same: signal name of destination, assignment operator, signal name of source, semicolon. as long as both signals share the same data types like integer in this case and having the same compatible range, you can directly assign the values of one signal to the another. For example, signal y gets the value of signal x semicolon. This statement will assign the current value of signal x to the signal y. Remember that it is crucial to ensure that x and y having the same range. Assigning any value to signal y that falls outside its defined range may lead to the unexpected behavior in your FPGA designs. In the next session, we will be talking about more useful data types supported by VSDL, so stay tuned for the updates. If you did not subscribe till now, then please do subscribe to learn and grow community for the regular updates. If this video is informative, then please like this video, comment on video, and don't forget to share. Thank you for watching.